Why got beatbox one? Okay, let us continue with question 2. When I explain, I also want to go through some basic. Okay, algebra. Whenever you see solve, there will be a equation. And then when we are talking about solving equation, we are always trying to find out what is the value of the unknown such that it balances the equation. Okay, so for example, I have another equation here. 2x equals to 6. If you are asked to solve, what it means is you want to find, no, that one is a step. But what they mean is they want you to find out what is the value of x. What number should be here to balance both sides of the equation. Okay, so this one, I don't need to do anything by looking. Actually, I know already. What is the solution? The solution is 3. X must be equals to 3. Okay, so solve is always like that one. We are finding what is this value that will balance this equation. Just that when the equation becomes very complicated, for example, maybe I have 3x over 7 plus 2 equals to 9. Then you cannot just by looking. By looking, you don't know what is x. What should be x to balance, to make the left also equals to 9. Okay? So when just by looking we cannot solve, then we need to write step by step. We need to write another equation, until we get what is x. X is 3. So this one, what is x? Then finally, your answer will also be x equals to something. So whenever you are asked to solve equation, definitely this is your final step. You want to get to this step. Then all the in-between is just logical. Whatever I do on the one side, I do it on the other side. So let us look at the question. I want to solve this equation. So, meaning, I already know my final step must be what is x. Then, how can I get from here to here? I need to write equations. This is where a lot of students, they get lost. They don't know or they are not able to write these equations. Okay, so let us go through. Then when we are working with algebra, we are doing our math, we don't want to work with mixed number. So we have to change the mixed number to improper fraction, or a fraction where the numerator is bigger than the denominator. Okay? So left hand side, when I'm writing an equation, left hand side I never change anything. So it can still remain as x over 8. I never change anything. Hello? But for my right hand side, I want to write it in another form. I don't want it to be in mixed number. So negative is still negative. But 1 and 1/4, I want to change. 1 and 1/4 means 1 and 1/4. But I don't want to write my 1 as 1. I want my 1 to be 4 over 4. Okay? So end up it will be 1 times 4 plus 1. Okay? I will have negative 5 over 4. When we have improper fraction, it is easier to work with. So, how do we write the next equation? Yes, I look at my left hand side. This is my endpoint. But right now it is x over 8. If I only look at my left hand side, how can I make x over 8 become x? I times 8 lor. Okay? Wishful thinking. I want it to become x ma, so I must times 8. So that it will cancel with each other. Then I am left with x on one side. Then I will get one more step closer to where I want my answer. If I concentrate just on this side. Okay? But because this is an equation, I started off left and the right, they are the same. So if I multiply 8 to the left, if I don't multiply to the right, it is no longer equal. They won't be the same. Logically, whatever I do here, I still want them to be the same. I must do the exact same thing to the right hand side also. I must also times 8. Okay? Then, when you do long enough, when you do enough questions, you will find that, actually this is just like my denominator, divide by 8, cross the equal sign, become times 8, become numerator. Okay? From divide by 8, it cross the equal sign, become numerator, becomes times 8. Okay? Then next time you'll see that the other way is also true. If I have something in the numerator, I don't want it, I want to divide it, it will go the other side, become denominator. Okay? Anything that is plus will cross the equal sign, become minus. Minus, cross the equal sign, become plus. But it came from multiplying 8 to both sides. Then this one, I can key inside calculator, or I can work out myself. 8 and 4 can cancel. Then I will come to my final answer, negative 10. What this means is, if I put in negative 10 back inside here, negative 10 divided by 8, it will end up to be the same as negative 1 and 1/4. If this value of x will balance the equation. Okay? So this is the whole idea of solving equation. Can? Okay, then using the same idea, let us look at part B. For part B, one thing to take note of is, we have two fractions. This fraction, the numerator is 2x minus 3. This fraction, the numerator is x plus 3. The two terms belong together, these two terms belong together. So whenever we see fractions with two terms at the top or at the bottom one, we add bracket first. Okay? It will help you remind yourself that they belong together. Can? Then I am solving equation. So, in between I need to write equations, but I write equations knowing that my endpoint is like that. I want to have x on one side of the equation, then I want to put all the numbers on the other side. This is my endpoint. So this is my starting point. In between is just getting to here. X on one side, all numbers on the other side. Every time solve equation is like that one. Okay? I want all my x on one side, and I want to put all the rest of the things on the other side. So from here, if I look at my original, my x is inside a bracket, then it appears at two different places. So if I want to work with the x, I need to remove the x from the bracket, and I don't want any fraction. Every time we solve equation, we try to make the fraction go away. So if I only look at the left hand side, if I only look at this side, I don't want fraction. So I need to do something. I need to do something with the left hand side so that it become not a fraction. Okay? There is a denominator 2. I want it to disappear. So I must multiply 2. Then 2 and 2 will cancel. I no longer have a fraction. At the same time, if I only look at the right, I have a denominator 5. If I want the denominator to go away so that I have no longer a fraction, I need to multiply a 5. Okay? But same, this is an equation. If I want to write the next equation, anything that I do on this side, I want them to be the same. I must do the same thing. So when I multiply 2, here I also need to multiply 2. Here when I multiply 5, I also need to multiply 5. Then they will still be the same. I can still say, next line, left and right, they are still equal. Okay? Then what is the result of that? The result of that is, these 2 will cancel with these 2. I choose one I choose the 2 to cancel one. This 5 will cancel with this 5. I choose one, purposely one. Then what will be left will be, on the left hand side, I am left with 5 multiply this entire numerator. 5 multiply the entire numerator on the left. Then what is left on my right? This numerator multiply 2 because the 5 cancel. So okay? Then a lot of the tuition teacher or other teachers, they will tell you this is called cross multiplication. This denominator multiply this numerator. This denominator multiply this numerator. So a lot of the tuition teacher, they teach students to remember by cross multiplication. But actually don't need to remember this one. You just need to know you want to cancel away the denominator. Then when you do long enough, you will know already. Just like what I tell you just now, the denominator cross the equal sign become numerator. Denominator cross the equal sign become numerator. Then it will end up like that. Okay? Because some students, they die memorize cross multiplication. When it's not the situation, they also just cross multiply. Okay? When I come to that, I will remind you all again. Okay? It only works when it is fraction equals to fraction. Then you will do the cross multiplication. Okay? Then coming to here, my x is inside the bracket. My x is inside the bracket. I cannot work with them separately. I cannot put them on one side. So I have to do my expansion first. 5 multiply 2x. 5 multiply negative 3. So 5 multiply 2x is 10x. 5 multiply negative 3, negative 15. Right hand side, 2 multiply x, 2x. 2 multiply 3, 6. Hey, y'all all finished, that's why talking. Is this too simple? Yeah. No, because if you don't listen now, then next time you still don't know. It's because you never listen. Can? Then now this is just expansion. Then I already know my endpoint. My endpoint is all the x on one side. So that my endpoint help me know what I want to do here. I want to put all my x terms on the left. So there are now 4 terms. terms are separated by plus and minus. So on the left, I have my 10x, I have a minus 15. On the right, I have a 2x, I have a plus 6. So I want all the terms with x to be on the left. So I want this 2x to go to the left. I don't want this 2x term to be on the right. So again, wishful thinking is, if I want this 2x to disappear, I need to minus 2x. Because 2 apple, take away 2 apple, I will have 0 apple, then I have no longer x over here. But because when I do this minus 2x, I have to do the same thing on the left. That is why, when I write my next line of equation, my 10x never moves, so my 10x is still here. Then my 2x looks like it crossed the equal sign, become minus 2x. Plus 2x, come this side, become minus 2x. Okay? This one is plus 2x. When we don't write, it is actually a plus at the front. So it cross here, become minus 2x. It is minus because it came about like that one. I minus 2x on both sides to make it disappear. Okay? By the same idea, my number 6 is on the right hand side. I never touch it. It is still 6. Positive 6 is still positive 6 over here. But my minus 15, I want it to disappear from the left. I want all my numbers to be on this side. So to make the minus 15 go away, I need to reverse it lah. Minus 15, I plus 15 no. Minus 15 plus 15, then it will become 0 ma. Then it will disappear ma. Okay? But this is an equation. So when I plus 15 on the left, I also plus 15 on the right. So that left and right are still the same. You want things to be the same, you must do the same thing to both sides. Then again, it will look like my minus 15 cross the equal sign, become plus 15. Then I am one step closer to my target. All my x are on one side, all my numbers are on one side. So 10x minus 2x, left with 8x. 6 plus 15, 21. Okay? I am one step closer to my destination. I want x, but now I have 8x. So to go from 8x to x, I need to divide it by 8. Because 8x divided by 8 will become 1x. But because I want to divide 8 on one side, I want to write an equation. I want the left still equals to the right. I must do the same thing to both sides. So, it looks like my 8 was numerator, is a multiply, 8 times x. It crossed the equal sign, now become denominator, become divide. Multiply, cross, become divide. That's why it become 21 divided by 8. Okay? Then this is my answer. This is my solution. If I put x equals to 21 over 8 back into here, back into here, left and right will be the same. Because I came from here, right, ma. I never change anything. Logically, every time I do one thing, I do the same thing. Okay? So this will get back this. Left, same as right. Yes? Huh? Okay, fraction is the most accurate, exact. So don't change to decimal unnecessarily. But if your decimal is come to an n one, exact one, it will also be correct. Yours is 3 decimal place, right? Yeah. That one is also correct, but it is not necessary. Okay? You can leave your answer in fraction. It is the most exact. Can everyone have an idea what is solving equation? Cyrus, why are you playing with stick? Okay, next one, inequality. Inequality, I think when you go through it in Sec 1 or Sec 2, the lesson is very short and very brief. So a lot of students, they don't really remember inequality. Okay, so let us go a bit more inequality. I write here. Okay, when we have equal sign means the same. My left hand side and right hand side. Equal sign means left hand side same as right hand side. But when we have inequality, like that, can you see that the left, this sign, it opens up to the left. The mouth is bigger. Then this side, sharp one. So it is smaller. So that is to say, whatever is on the left is bigger than the right. The sign is like that, ma. It opens up to the left, so the left is bigger. We read from the left to the right. Bigger than. Larger than. So the left hand side larger than the right. Then, if like that, then the left hand side is smaller than. Okay? Can? This is inequality. Then, how does it work? How are we going to solve inequality? Actually, no difference, not much difference from solving equation. Okay? If we are adding and subtracting, Ryan, Cyrus, why you all so busy one? You all busy doing what? Huh? Later lah. Follow first. That one is just now that question. Don't understand. Huh? Okay. Inequality. Let's say I start with 2 larger than 1. If I add another 10, add another 100, let's say I add another 100 on both sides. I do the same thing on both sides. 102 compared to 101, 102 is still larger. Okay? Then if from 102 and 101 I minus 50, let's say I'm left with 52. Minus 50 become 51. Still, my left is still larger than my right. So addition, subtraction, my inequality don't change side one. Left larger than right. If I add or minus the same thing, my left will still be larger than right. Okay? But if I multiply, then sometimes it may change. 2 larger than 1. If I multiply both sides by 3, it will become 6 and 3. Is 6 still larger than 3? Yes, right? So no change. Okay? But consider, if from 2 larger than 1, I multiply by negative 3 to both sides. 2 multiply negative 3 become negative 6. 1 multiply negative 3 become negative 3. Then when you consider negative 6 and negative 3, let us look at the number line. 0, 1, 2, 3, 4, 5, 6. Going to the right is positive, becoming bigger and bigger. Okay? Then when we go negative, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Towards the right is bigger. So negative 3 and negative 6. Which one is bigger? Negative 3 is bigger because things towards the right is bigger. So now change already. Negative 3 and negative 6, negative 3 is bigger. Okay? So the inequality, the only difference with equation is when we multiply or divide by a negative number, this sign will change side. Other than that, how you work with inequality is exactly the same as equation. Can? So, if we look at this, they want us to solve, meaning the endpoint is also the same one. My endpoint will be x on one side, then all the numbers on the other side. This is my endpoint. This is what I start with. So I want all the x to be on this side. Then this x is already on this side, I keep it. I want this 3x to come to the left instead of on the right. So plus 3x. I don't want it to be here. I need to minus 3x. Cancel it away. Then it will appear on the left. Then I must do the same thing on both sides. That's why it come over here become minus 3x. I am adding and subtracting, so the sign don't change one. I'm only adding and subtracting. Negative 9 was here, no change. But my minus 3, I don't want it to be on the left, I want it to be on the right. So I need to plus 3 on both sides to cancel it away. Plus 3. Then here also must plus 3. That's why it appears on the right as plus 3. Yes. Hey, wait. After this question. Then, okay? Then simplify. X, take away 3x. Meaning, I go one step positive, I go back 3 steps. Plus 1, but minus 3. So end up, I still have minus 2. Okay? So negative 2x. Positive and negative, they are like two opposite direction like that. Plus, go one side. Minus, go the other side. So minus 2x. Then here, minus 9 plus 3. Still have minus 6. Then I want x, I don't want minus 2x. So I will need to divide by minus 2. So that cancel, I'm left with x. Because I divide by minus 2, right hand side I must do the same thing. Then here comes the special part already. I am dividing a negative number. So just like just now, multiply or divide. When I multiply a negative number or divide a negative number, the sign will change. So when I divide by negative 2, negative 6 divided by negative 2, positive 3. But because I divide negative number, this sign going to change side. From right side big become left side big. Okay? So this is the solution for your original inequality. Okay, let me finish this question. So, what I want for all my x is x bigger than 3. It can be 4, it can be 5, it can be 6, it can be 3.1, 3.2. X must be larger than 3. So if I have a number line here, where are all the points, where are all the numbers that are bigger than 3? It can be all on this side of the graph. Because here 3, 3.5, 4, 4.1, 2, 3, 4, 5 like that. So everything to this side is part of my answer. So how do I write? I'll answer the question. Show people that I want all this. So I start with here. I draw one arrow like that to show that from here everything here is the answer. Okay? Then the starting point. There are two kinds of starting point. One is a solid dot, one is a hollow dot. Whether we use solid or hollow depends on if we want to include this point or not. Because solid means you are there. Hollow means it is empty. You are not there. So, to determine the starting point, we need to look at our inequality. This sign like that means strictly larger than 3. X cannot be 3. X must be larger than. So 3 itself is not my answer. My X is larger than 3. So 3 itself is not included. So I need to use the hollow dot. Because 3 itself is not my answer. So I must have a hollow dot here. Okay? If I want to include the 3, then my inequality cannot use this sign. I have to use the other sign. X larger or equals to 3. This one X can be equals to 3. There is an equal sign here. But this one means X strictly larger. This one X can include 3. But now, what we are given was strictly smaller. So, even when change side, it is strictly larger. So, we don't include 3. We don't include 3, that's why hollow dot. Okay, follow so far? Okay, go toilet. Then everyone take a break lah. Until he come back from toilet. Again, next time when we see this question. Okay, continue ah. Yeah. Okay, next question. Jendelin, are you okay? Okay, when we whenever we see a graph, we must first try to understand what the graph is telling us. We try to make sense of what is happening. Cyrus. Okay? So when we look at the graph, we try to make sense of what it is telling us. Then we look at the axis. The horizontal one is number of children. Then they put 0, 1, 2, 3, 4. So, all this along the x-axis, the horizontal axis, is no children. This bar, no children. This bar, 1 children. This bar, 2 children. This bar, 3 children. This bar, 4 children. Then we look at the y-axis, the vertical. Cyrus! The vertical axis say number of families. Okay? Meaning, this number along the vertical is number of family. How many family? So when we look at the first bar, 0 children, then it reached this height. This height, if we read to the y-axis, every small dot is 1. So 10 small box become 10. So if we read here, 1, 2, 3, 4, 5, 6, 7, 8. Here, the number is 8. Okay? Then you should roughly have an idea already. 8 family got 0 children. Can? So this is how we make sense of the diagram. We go to the x-axis, we go to the y-axis, then we can make sense. Then here, 1, 2, 3, 4, 5. So it is 15. 15 family got 1 children. Here 20 family got 2 children. Here 12 family got 3 children. And 5 family got 4 children. Okay? So before you answer any of the question, you can have an idea what this graph is telling you already. Then when you know what this graph is telling you, then you go and see the question, it will be a bit easier. Okay? How many families have exactly 2 children? Okay? Then you go to 2. Then you go and read, 20 lor. 20 family got 2 children. That's why the answer is 20. How many families are there all together? Here got 8, here got 15, here got 20, here got 12, here got 5. So we add up all these numbers together. Then you will have 8 plus 15 plus 20 plus 12 plus 5 equals to 60. Very good. Okay? How many children are there all together? Can very good. Okay? Individually, this family 8 got 0, so 8 times 0. Here, 15 family got 1, that's why 15 times 1. 20 times 2, 12 times 3, 5 times 4. Then you add them all together. Add them all together, you get 111. Can? So this question not difficult. Then next. Okay, this one the question got problem. So maybe that's why some of you have problem answering. Okay, these 3x shouldn't be here. These 3x shouldn't be here. They only want you to know x is 90 degree. So the value of x is 90. Okay, but the question got problem, that's why confusing. Can? Okay, the difficult part is 22 students prefer Milo. How many students took part in the survey? Okay, so what they are asking you to find, Xander, or what they want you to think is Milo. So Milo is this piece over here. So they want you to actually compare this piece like that, 110 degrees is actually 22 students. Okay? Then the total student, total means the entire circle. So entire circle means you have 360 degrees. So 360 degrees is how many students? That is what they want you to find. That is the whole idea of this question. 22 student Milo. Then altogether how many? So this one is a direct proportion question. Okay? So if we were to answer, it is 110 degrees is 22 students. Then how many students is 360 degrees? So from 110 to 360 is a bit difficult to straight away jump like that. So when we have this kind of proportion question, it is easier to go and find what is 1 degree first. Then it's a bit like equation. From 110 to become 1, I need to divide by 110. So same, then I must do the same thing here. I must also divide by 110. Then I will have every 1 degree is 22 over 110. Then from 1 to 360, it is more straightforward already. I multiply 360 lor. Then I do the same thing lor. Multiply 360. That is why 360 degree, I will have 360 times 22 over 110. When I press calculator, then I can find the answer. Is okay, how many? 17. 70. 72. Okay? Can? Okay, 10 minutes. We can start with our chapter 3. Why? Sooner or later have to start one, ma.